Hello everyone, my name is Oshi and today we'll be discussing about Kyverno, a policy engine for Kubernetes. Nowadays, Kubernetes has become a default standard for managing containers at a scale, as it can be configured and installed in n number of different ways, and it is good in terms of flexibility, but it can lead to a security breach. So to make it secure by default, different security policies like pod security policies can be imposed, as this policy impose rules and conditions on the deploying applications. And for this, policy engines like OPA, that is Open Policy Agent, and Kyverno help us in deploying such policies. OPA is also an open source general purpose policy engine that uses a highly declarative language Rigo, which has a steep learning curve. But on the other side, Kyverno, which is a Greek word for govern, is also an open source policy engine, and it is especially designed for Kubernetes as it allows policies to be written in YAML, and it also comes with a command line interface for testing policies. Kyverno also helps in simplifying, validating, or imposing best configuration practices in Kubernetes cluster. Before going further, let's click on this lab setup button, which will set up a lab for us. As Kyverno is implemented using the features of admission controller, so let's take a quick look on what admission controller is. Admission controller is basically a code that intercepts the request coming to the Kubernetes API server, but after first it is being authenticated and authorized and before restoring it into etcd. So basically it is regarded as a checkpoint for Kubernetes API request, and it can completely deny or accept the request or change the request object also. And for this, dynamic admission controllers like validating admission webhooks and mutating admission webhooks are used, which can validate or mutate the request that has been sent by the user. Like in this diagram, where an incoming API request is first being authenticated and then sent to the admission controller for inspecting the API request, and later on, it is being sent to etcd for restoring it. As Kubernetes admission controller helps in inspecting the API request, but writing a custom admission controller for each use case can be tricky. So policy engines like Kyverno and OPA are used for it. So how does the Kyverno uses this admission controller? Kyverno basically receives the validating and mutating admission request from the Kube API server and applies with the matching policies it has, and then send back the results that allows admission policies to be imposed or reject the request. Like in this image, where an incoming API request after first being authorized is being sent to the Kyverno for inspection with the help of dynamic admission controllers, and here the monitor component inside the webhook takes care of the configurations like about secrets and webhook configurations, and then the policy controller inspect the request with the help of policy resources it has to accept or deny the request. And if there is a need of generating a new resource, then the generate controller helps in managing the lifecycle of the generated resources and then send back the request and store it into the etcd. Kyverno has some predefined rules on how to write mutate policy and validate policy. To write a mutate policy, JSON patch is used, and under the mutate attribute, some conditional logics like if then else has to be specified. And to write a validate policy, under validate attribute, patterns along with operators has to be defined. For this, we will be seeing in a while on how to write validate and mutate policy. Next, we will be going to see on how to install Kyverno in the Kubernetes cluster and how to apply different policies with the help of Kyverno. So Kyverno can be installed with the help of Helm chart or through kubectl. For now, we will be going to install Kyverno with the help of kubectl, and this will make Kyverno to run as a pod inside the Kubernetes cluster under the Kyverno namespace. And this can be verified with the help of kubectl getpods command. And let's wait for some time till the status of it gets in a running status. We can also see the Kyverno pod configurations with the help of kubectl describe pod command. And as you can see here, we are seeing different details like what labels this Kyverno pod has, on which IP address it is being serving, details about image, pod, and so on. We can also see the details about dynamic admission controllers, that is validating webhook and mutating webhook with the help of kubectl get command. Next, we will be going to see how to create policies with the help of Kyverno. And for this, first I am going to create a validation policy which will validate for labels on pod resources, and we'll check if a label is present or not while creating a pod. For this, I'm going to create a policy with a kind cluster policy, which will make the policies to be applicable on cluster-wide resources. You can also create another policy with the help of kind policy, which will help us to apply policy on a particular namespace resources. For now, I'm going to create a policy with kind cluster policy, and under rules attribute, I'm going to specify on what resources I want this policy to be applicable, and under validate attribute, I'm going to specify what labels it should have while creating a pod. And if the policy gets failed, then what message it should give while giving an error. Next, you can see that there is a policy attribute, that is validation failure action, which has a value of enforce, and this will block the incoming API request if the policy gets failed on a resource. There's also another value we can use, that is its default value, that is audit, and this will report violations if the policy gets failed, but it will not block the incoming API request. Now I'm going to apply the policy with the help of kubectl apply command. And as we have created cluster policies, so we can see different cluster policies running in the Kubernetes cluster with the help of kubectl get cluster policies. As of now, we have created only one cluster policies, which has an action set to enforce value. Now I'm going to check the policy by creating an nginx pod, but without specifying any labels. So on executing, it will raise an error with the message that the label is required. Now again, I'm going to create the same nginx pod, but with this time, I'm going to specify labels also. So on executing, it will allow pod to be created, and we can also delete the cluster policies with the help of kubectl delete cpol, where cpol is the short name for cluster policies. The next policy we will be going to see is again of validation policy, in which I am not allowing the pods to be get created in the default namespace. For this, again, I am going to create a policy with kind cluster policy, and under rules attribute, I am going to specify on what resources this policy can be applicable. And under validate attribute, I am going to specify that default namespace should not be there while creating a pod with the help of this not operator and default namespace. And if the policy gets failed, then it should show an error with the message being specified here. Now again, I'm going to apply the policy with the help of kubectl apply. Now I'm going to create a pod in the default namespace to test the policy. And as you can see, it is giving an error with the message that a default namespace is not allowed. Now I'm going to create a new namespace test, and then I'm going to create that Alpine pod in that test namespace, as we have only disallow pods to get created in the default namespace. Now again, I am going to delete the cluster policies for further example with the help of kubectl delete cpol command. The next example we will be going to see is about mutation policy, in which I am going to add labels as we create the pods and other resources. Again, for this, I am going to create a policy with kind cluster policies, and under rules attribute, I am going to specify on what resources this policy can be applicable. And under mutate attribute, I'm going to specify what label I want while creating a pod and other resources. Now on applying the policy with the help of kubectl apply, and then creating a Python pod to test this policy. Now I'm going to execute kubectl describe pod command to see if the labels has been added or not. And as you can see that the labels has been added in the Python pod. So in this hands-on lab, we have seen about the working of Kyverno policy engine and saw how to implement policies in the Kubernetes cluster. Thank you.